Hello friends, welcome back to my channel. Now in today's video, we are going to look at how to build an intelligent document processing system. And for this, we are going to use Amazon services or AWS services. And the main services that I'm going to use are Amazon Textract and Amazon Bedrock. So this intelligent document processing, cut short as IDPS, is going to automatically extract data from files that we upload to it. The data can be in the form of a form, an invoice, a receipt, a contract, or any document. What our code is going to do, it's going to utilize Python as our programming language, and then we use Textract. Textract is a machine learning based service from AWS that automatically extracts texts, handwriting, layout elements, and data from scanned documents. So when we upload the file, Textract is what's going to help us to extract all those components on that particular file or receipt or invoice. And then from there, we are going to use a fully managed service from Amazon known as Amazon Bedrock. Now this offers the choice of a high performing foundation LLM model and also provides the tool to deploy and operate agents. In a previous video, we did look at RAG AI, and for that, we built it from the ground up with a base of foundational LLM model. In that project, we parsed our data, we tokenized it ourselves, we embedded it, and embedding just means converting the tokenized data into numbers to be stored in a vector store. And then we stored these embeddings in a vector store. I remember we used a phase vector store, and then we deployed the transformer. But Amazon Bedrock makes it even simpler, in the sense that we don't need to do all that. We just need to enable Amazon Bedrock agents on our local machine and then directly call it from AWS. So we will need a utility that will help us to call the agents. And that's where we will use Boto3, which is the Python SDK for Amazon Web Services or AWS. So that will make it even more easier to build a RAG AI system. So let's say, for instance, this is our document. Now this is a sample invoice that I downloaded from online. Let's say this is our invoice and we want to extract data from this. In that case, Textract is going to help us in our Python code to extract every single line of writing. So we will have a new file that looks like this. So we start with an initial file that is plain. We extract the components. And in this case, I use a red rectangle drawn around each component that we extract from the file. That would make it look like this. And then when we extract the data from the file, all the components that had the red rectangle around it will be extracted like this. So you see that every single component that you see in the red box are all extracted over here like that. Now this is all with the help of Textract. And then from here, I'm going to add another component where we interface this with an LLM based service, which is Bedrock, so that we can query it. So let's say if we ask the application how much was the taxes on, let's say, cost of various services, it should be able to extract that out of the file and display it for us to see. Basically to make it reasonable like a human being. So that's how this project is going to go. Now, I'm still a new channel and I'm trying to grow, so please like, comment, and subscribe to my channel for more videos like this. And now let's get into it. By the way, if you have any questions, leave them in the comment section below. Now, before we start, let's look at some business value and prerequisites for this app. Now, first, for the business value, this is going to reduce manual data entry by about 90% approximately. It's also going to speed up billing, auditing, and legal workflows for a company. It's also going to minimize human error and provide auditable logs. So these are some value that this kind of application, which is an LLM-based application, can present to a company that actually uses it. Now for some prerequisite, we need, of course, our AWS account. And we are also going to create an IAM user. And then we are going to need Amazon Textract which is a machine learning service that automatically extracts text from a file or a document. Now this text can be handwritten or typed, it doesn't really matter. And then we need Bedrock, which is our fully managed service from AWS, which offers the choice of high-performing foundation LLM models and also how to deploy them. You're also going to need AWS CLI installed and configured for our IAM user. We need Python, of course. Now, the Bedrock and Textract supports Python 3.8 and up. And then we are going to need some front end to interact with the app. For that, we will use Streamlit and some other dependencies that we will need. Now, the architecture will look something like this. You will upload a file or a scanned document. In this case, it will be an image. And then we will use Boto3 to call our Amazon Textract API. And then we use Textract to parse the results and then return some text or blocks. Now, the text or blocks that Textract is able to parse, we will draw bounding boxes around it just to show how good our extraction actually is. And that's exactly what I showed previously. And then from there, we are going to deploy the Amazon Bedrock. And for this example, I'm going to use the Anthropic Cloud version 2 LLM model to create a simple RAG system for Q&A based on the context of the document that we uploaded. Now, in order to start, we are going to use Python, of course. So we need a Python virtual environment. I'm going to run this python-m vmv command to create a virtual environment here. It's created. Now we need to activate it like this with the source command. It's activated right there. Next, I'm going to create the requirements.txt file, which will have our required dependencies or packages. Touch. That's our requirements.txt. And for the packages, we are going to need Boto3. We need Streamlit, of course, for our front end. Pandas. We need Pillow. AWS CLI. I don't know if you will need NumPy, but I'm just add it for now. I'm pretty sure most of these are familiar, except for maybe Pillow. Pillow is a package in Python that helps you to import or open images and draw on images in Python. Okay. So this is our requirement.txt. Let's install it. I've saved it, so I'll use pip install -r requirement.txt to install it in our virtual environment. So press enter. Okay. Next, we need to set up our AWS CLI. And for that, you can easily go to your browser, search for AWS CLI, install. AWS pretty much has a link for all the installation for different OSs right there. It's pretty straightforward. I already have it installed on my system, so I'm going to check AWS -- version. And this is the Python version installed 3.12. And I have Boto Core 1.40 also installed. Next, we need to go to AWS and create an IAM user, add some access keys. You will need it to configure it from the terminal. So you have to download the CSV file, and then we will use AWS configure to configure it on our terminal. All right, let's go and create our IAM user on AWS. This is my AWS. I'll just search for IAM. Can go to users. So you have some users here. I'm going to create a new user. Now call this IDPS Bedrock. Now I only need CLI access for this, so that's okay. Next, I'm just going to attach admin access, but you don't do this in production environment. Okay. Next, create user. And that is our user right there. Click on it. In here, you see there's no access keys, so create access keys. And of course, it's via terminal, so select CLI, understand the recommendation. Next, you can add a tag if you want to, but that's okay. Create access keys. Now, these are your access keys and the secret access key. Download the CSV file onto your computer. This is it right here. I'm going to open it and use that to configure it from my terminal. And then on my terminal, let me clear the screen for now. AWS configure. As for the access key ID, make sure that we copy that correctly. Paste this here. And then the secret key ID, this is it. Copy this one as well. Paste this here, press enter. The region, I'm just gonna keep US East 1. And then I'll press enter for default output, which is JSON. So AWS IAM user that we called IDPS Bedrock is configured on our terminal. So I can select done now. Next, you need to make sure that the Amazon Bedrock is also configured or enabled on your system. So on your AWS Management Console, you can go to Amazon Bedrock. This is it. Here is it. When you come here, you can scroll down under the configure and learn, go to model access. Now there are so many models that you will find here. So many LLM models. Some of it you may have seen it before. Llama, Anthropic, Cloud, and all that. Initially, if you haven't used it in the past, you see that you will have no access to these models. You see a tab here which says grant access to the models. Click on that and it will ask you for a few particulars like the company name, website, what you're using it for. You can pick educational purposes and it will be approved within a few minutes. Once it's approved, you will see access granted written next to it like this. Now, even though you see access granted, this doesn't bill you for anything. It's only when you invoke the models that you are billed for it. So it doesn't cost anything for access being granted to these models. Currently, I have most of the models access granted. Now, sometimes some models are not available in certain regions, which is why I use US East 1. Most of the models are accessible in the US East 1 region. Now with that, let's write our application. I'm gonna call it Streamlit app.py. And then I'm gonna import my packages. Just gonna copy the packages and paste them here. Like this. These are the packages that I'm gonna need. We have Streamlit, Boto3, and Botocore as well. PIL, which is the pillow package that we installed. This one. And that's for images and image drawing. IO, JSON, pandas, OS, and typing. Now each of these have different purposes. Pillow is also what's going to help us to draw red rectangles around the text that I showed earlier. Protocol exceptions is just going to help us to catch any AWS client errors. And of course, Boto3 is the SDK for AWS for Python. IO, this is just going to help us to load the uploaded image without saving it to any disk. JSON, as you can tell, this is going to help us to parse data on the image that we upload in order to help Bedrock to format the responses. Basically, it's going to serialize the stuff on the document. Typing, this is just going to help with readability. In the past, usually I would copy the code that I used to create a project and then paste it in here and run it. But I kind of miss typing the codes myself. So in this project, I'm going to type it out myself. But I'll add comments as I move on. First, let's do our AWS config. I'll do AWS region. This will be an environment variable. OS get environment. I'm going to call AWS underscore region. And this region is US East 1. By the way, I will set this environment variable. I believe I added it to the README file here. I'll add it to my terminal as an environment variable like this using the export command and bash. And so when I run this Streamlit app with this OS get env, this will automatically pick up US East 1 as the region. Now let's look at the AWS client. First, you need to initialize a session, and that is from Boto3 session. And then we are going to call Textract. This will be called from the session that we initialized, client Textract, and the region underscore name is going to be this AWS region. So copy and paste that there. And then you have Bedrock. Let's call it Bedrock runtime. And this is also going to be called from the session client. And we have Bedrock dash runtime. Again, the region underscore name gonna be AWS underscore region. The environment variable is specified earlier. So these are the clients for AWS. So let's create some page layout stuff. For this, I'm just gonna copy and paste it in here. Just some simple Streamlit stuff. So this is just gonna create a page first and a title. And this is just gonna be a markdown for uploading image for a document. The next step after this is going to be the image that we want to upload. Let's call it uploaded file. And this is going to be streamlit.file uploader function. So it's going to display upload document. And the document type is going to be PNG, JPG, JPEG, TIFF. If you want to add more file types, you can. But for the meantime, I'm using these 4 file types here. Okay, next I'm going to create a function. In Python, use def to define a function. I'm going to call it extract text from response. A response is going to be of type dictionary, and then the output or the return function is going to be a string. Now this is going to extract all the text from Textract response in a reading order. So first, when you use Textract, the first thing you need to do is to pull out the blocks array. So I'm just going to call it blocks. And we get it from the response.get, and that is from the blocks. If you don't get anything, or if there's no text, it will just default to something missing or empty. That is for no text identified. And then we are going to look at only blocks that represent text lines. So I'm just going to call it lines. So for B, in the blocks that we defined earlier, if the block type is a line, then return B. Next, we are going to take all the text that we are picking up on each line and then put all of them together as one document, or put them side by side as one big string. So I will call this text. Take each line and join. For the text in here for L in lines. So L represents the number of lines that we have collected, and then we will create a single big string from all the text that we've extracted. And at the end of the day, we are going to return this text. Next, I'm going to create a function called ask bedrock question. Now this is going to be a function that sends Q&A prompts to our LLM model on Bedrock. And so the input is going to be the context, and that is a string. The context is going to be the document we uploaded, and then the question that we ask, which is also a string. And this is going to return, let's say, optional string. So I'm going to paste the first component down here. So what this is doing is it's building a multi-line prompt. Now this style that you see here with the prompt like that, the document context, the question context, assistant, this is the Anthropic style, which is in a sort of human assistant format, right? So this is the human format, assistant format. So what this is going to do is it's going to extract full context from the document we uploaded, and then from the question that we asked based on the document, and then the assistant is going to queue the model to answer. So all of this is going to be inside this function defined as ask bedrock question. Next, I'm going to use the error handling for bedrock call. I'm going to try something, but if it fails, I'm going to add exception. Of course, the exception is going to be the client error from AWS. It's defined that as E, and this is going to return an error. And the error is AWS Bedrock error, and we labeled the client error as E. right there. And this is going to return nothing. Now let's put the actual execution inside the trial component. So you have a response. Now, if you want to call the Bedrock function, remember we defined the Bedrock right here. The client is Bedrock runtime. So we need to call Bedrock runtime here. But if you want to call that model itself, we use the invoke underscore model function. And then everything else is going to be in here. We are going to need model ID, which is going to specify the model that we are actually going to use. We are going to need a body, and the body is going to be JSON dumps. This is just going to be the JSON encoded parameters. Now, earlier I did mention that we are going to use the Anthropic Cloud Model version 2. So I'm just going to copy the name for that. So that is the Anthropic model. And for the dumps, just specify some encoded parameters that we will need for this model. I'm going to copy it, paste it in here. We have a prompt. Now this prompt is going to come from the prompt that we feed the model right there. The maximum number of tokens, this is just going to cap token that we use at 1000. The temperature and top P, these are all parameters for sampling. Then content type, of course it's in JSON format, so I'm going to use application JSON. Now, once this is done, you need to return some results. So I'm going to define result. This is going to be some JSON file. The result is already generated, so we just need to load it. So we are going to load the response, not just the response, but the body of the response. We need to see it, so I'll use read. And now we can return the result completion. Now the completion is just the completion text that is remaining from the body of the results that we generated. Usually when you extract the results from the JSON format, there will be white spaces. So you need to strip it to remove all the white spaces. Okay, so from start, we've uploaded a file, or we have the function for extracting text from response, a function for loading our LLM model from Bedrock. Now we need to process the document a little bit. This is just going to help Textract to extract or to find the uploaded file bytes that they will use for the OCR. And OCR is just optical character recognition, just to help you to recognize the different characters, right? So for that, I'm going to create some more functions. The first one is process document for Q&A. So let me just make it QA as short. Now this is going to collect the bytes from our file. So I'm going to call it file bytes, be of type bytes. And the response is going to be optional dictionary. Again, I'm going to use the try an exception block. So I'll try something, and if it doesn't work, we'll have some exception here. And the exception is going to be client error. That is our exception. Now let's try the actual function execution. This is going to return a response, Textract, and this is going to detect some document text. In the document, we have bytes of that document. We will call 5 bytes, and we will return this response. Okay, next, let's write a function that will draw the rounding box around our text when we do the text extraction with Textract. So this will be another function here called draw bounding boxes. In the inputs, you have image, you have blocks from Textract earlier, remember? And the color for the bounding is going to be a red box. And for the width, let's say 2. So I'm just going to copy the code block for this, paste it in here and explain it. Okay, so this is going to define a function that overlays rectangles. And by the way, it's red rectangles for each line that is detected. It's not going to do it on the original file that we upload. It's going to first create a copy of that image. And then from that copy is what we are going to be drawing the rectangles on. Now over here, this for loop here, it's just gonna iterate over all the blocks that Textract is able to identify. So it will look for all the lines. Remember the block type we used earlier from Textract is lines. So each line you have different blocks on it. This will iterate over all the blocks on a line. This is just for the dimension of the boxes that we are gonna draw. We are just gonna draw rectangles, and this is just gonna be its dimension. By the way, we specify the color already up here. And at the end of the day, this is gonna return that image, which is a copy of the original one with the boxes drawn around different blocks of letters or words. Now, the next stage is where we need to specify our main application logic. So suppose a user is using this app and he enters an image or a document. What's going to happen? That's what we are going to do now. So this stage is just going to be calling the function that we've written already so far. First, we need to be sure that the user actually uploads an image. So I'll use an if condition. If we used uploaded file earlier, that's why this shows here. This is it, uploaded file. So if some document is uploaded, then we can actually go on to do what we want to do. So if uploaded file is not empty, so that is, it's not none, then we can collect the file bytes. And that file byte is going to come from the uploaded file.read. By reading it, we collect the file byte. Now, in order to make sure that the document that is uploaded is more of an image, remember the document types here I used, all of these are for images. You can also add PDFs, but you have to write functions for that as well. I didn't want this to be too long, so maybe later I will do that. So in order to make sure that the document uploaded is an image or is in the correct format, I'm going to add another if condition for the file type. And this is the file type dot starts with, and it should be an image. If it's an image, then you're going to have the original image. It's going to be the image dot. Let's open that image and the file bytes. All this is going to do is to wrap the bytes of that image that we uploaded in memory stream, that is bytes IO. And this is also going to help us to open the image. So in the next line, I'm going to use streamlit.image to load the original image here. And I'm going to give it a caption called uploaded image. Now, another thing we also want to do is to see the extraction that Textract actually does. And for that, we are going to use a spinner status in Streamlit to do that. With st.spinner for processing with Amazon Textract. Now this spinner is going to show this whilst we are calling Textract. The function is going to return some response, which is Textract's response. Okay. Now I've already used response in the past, so I'll just call this resp. And this is going to be from analyzing or processing the document that was uploaded for Q&A. So I'll call this the process document for Q&A. And then call the file byte in here like this. Now, if a response is returned, then we can now call our, let's say, extracted text. We call the extract text from response function on this resp. We need to display it, so I'm going to use Streamlit expander. Expander is just when you click it, it can show you. When you click the same bar, can also hide it. View extracted text. And this will show extracted text. We need to also visualize the image that has the bounding boxes. So for that, create a subhead or a subheader in Streamlit. Call it bounding box visualization. So I'm going to call boxed img. We will call the function draw bounding boxes that we defined earlier around the original image that we uploaded based on the response that we have from our Textract blocks. And then we need to show it. So boxed image. Let's add some caption. Let's call this detected text with bounding boxes. Next is the question and answering section. So I'm going to create another subheader. It's called this document question answering. All right. So question, text inputs in Streamlit, which is going to have the text ask a question about the document content. Now, if the user types a question and some text is extracted from the document, then we can create a spinner. The spinner will act like it's thinking. So searching for an answer, something like that. The answer is going to be called from Ask Bedrock Questions, the function that we created earlier. And the context is going to be based on the extracted text and the question that we provided. Now, if there's an answer, then Streamlit will display success. Answer equals whatever answer we were given. If there's no answer, then Streamlit is going to display warning. Let's give it some generic statement. Let's say could not generate an answer for this question. All right. So that would complete our main application logic. So now it's up to us to implement it or to deploy it. Every command that we need is in our README file here. Pretty much finished with all these. If you want to run the Streamlit app, you use Streamlit run and the name of the Streamlit script that you use. So I'll just copy this, paste it here, press enter. So it's open on localhost 8501. I'll copy it and go to my browser, paste and go. And this is our application right here. Right. Now to test the app, I have some documents that are prepared for testing it. So I'll just copy them and make them available in our projects directory. Okay, so these are the files that I'm going to try them with. These are some sample invoices or text that we are just going to try to see if our code can actually extract text from these different files. All right, going to close this. Now let's go back to our browser. Go to browse and let's go to where our document actually is. So these are all the files that we are trying out. Now the one that I used earlier to show us an example or illustration is the first file here. So I'll select that. And this is the original. So this is the expander for extracted text. So if you click on it, you see that all the text that it's able to extract from it will be shown here. And this is how the document looks. You see everything is boxed in a red rectangle. I see that it's a little tight. You can increase the dimension of the rectangle in the code in this region here. You can just increase it a little bit for it to be a little more readable. And then this is the RAG part of it. This is a Q&A section. I provided some questions in the README file that you can ask it. So here are some questions that you can ask it. What is the invoice number? So let's go here to the app. This has an invoice number, right? There it is. Let's see if it can correctly give us the invoice number. So what is the invoice number? Press enter. So it's searching for the answer and it says, according to the invoice document context provided, the invoice number is INV 112. That is exactly that, INV 112. Same thing here, INV 112. So that is correct. There are some more questions here that I'm going to try. Next question is, what is the total amount? Who is the recipient and stuff like that. So I'll just try them out. So what is the total amount? Now, if you don't want it to go on and on, you can ask it to be brief and concise. Press enter. It says the total amount is 1,699.48. And you see that right here. Let's try some more questions. The next question is, who is the recipient? Based on the invoice context uploaded, the recipient is your client. It gives the name, the address, and you see billed to. That's our recipient. What is the address of the recipient? See, it gives the correct address. How much in total was charged for consulting? Let's tell it to be brief. The amount charging for consulting was $1,125, and you see that consulting is $1,125 Friday. $1,125 Friday. You see that it's able to correctly extract the text and give you the correct answers every single time. Next, let's say, what are the terms of the invoice? Press enter. The terms are, please pay within 30 days using the link in your invoice email. And that is a term below the text right here. At the end of the document, you see, please pay within 30 days using the link in your invoice email. Let's try a different document. Let's use this text here. Now this is more like a story, like a short story, and you see the boxing is also done correctly here as well. And you can still ask it different questions. Now this question is not related, so it will hallucinate. Now based on this document, I read it a little bit, so I know some things in there. I saw a name called Frank Winfield, so I'll ask, who is Frank Winfield? And it will tell you who that is based on the document and the text that was extracted. And that is it. And if you read the document, you see that this is correct. Last question, what did Frank Winfield invent? Be brief and concise. Press enter. He invented price tags for goods in stores. Maybe let's try one more document. This one right here. Now this is a land purchase agreement. And this, you can see it's correctly extract everything. Now this question is not related to this document, so I'll remove it. And I'll ask a question related. So let's say, how is the balance at closing going to be transferred? Be brief and concise. So we purchase a land. We want to know how the balance that is remaining is going to be transferred based on the documents. If you press enter, it says the balance at closing is $540,000, will be transferred via wire transfer. And you see that right here. See, the balance is $540,000 at closing via wire transfer. So it correctly catches that. So that's what I wanted to show in this video about how you can build an LLM or generative AI based application using Amazon Bedrock and Textract as well. If you have any questions, keep them in the comment section below. Like, comment, and subscribe to my channel for more videos like this. And now, before we leave, I need to close this. Use Ctrl+T to exit out of this as well. But before I upload it, I need to remove the virtual environment. I call it IDPS VMV. I should have deactivated it first, but everything is saved. So I'll push this to our GitHub repository, and I'll put a link in the description below if you want to try your hands on it. Like, comment, subscribe, and share this video, and I'll see you on the next one.